All right, so part F, we're asked to find the slope of f. So if we go up and look at the function we were given for f, we had 12.1 times t plus 14. Okay, so our slope coefficient on our variable here is 12.1. And a slope we need as a ratio of change in output to change in input. So we can always take a number and divide by 1. 12 divided by 1 is still 12.1. But that gives us a change in output in the numerator and a change in input in the denominator. And so our units here, output was in billions of worldwide emails sent daily, and our input was in years since 2000. Okay, so if we interpret this result in context, we always start talking about the input variable as we change what happens to the output or response variable. So in this case, we can say that for every additional year since 2000, we expect the number of worldwide emails sent daily to increase by 12.1 billion on average. Again, a slope is a ratio of two changes, change in output to change in input. So we need language in here that talks about changing things. So every additional year is our +1 that we see here in the denominator. And then our numerator, we've got a positive 12.1, which is why we've used the word here that we're increasing by. But now, if we look at the slope of f inverse after we had rewritten that function in this ax plus b type format, we had about 0.083 t minus 1.16. Okay, so now our coefficient on our variable in this linear expression is 0.083. So 0.083, and as a ratio we can divide by 1. And again, for our units, we've now reversed our input and output columns. So these are reversed from what we had here. So now our output is years and our input is billions. So now this tells us for every additional billion emails sent daily, years since 2000 increase by 0.083 years on average. So again, slope is a ratio of changes, change in output to change in input. So again, we need language for changes. So our denominator here, increasing by 1 billion, is our input variable. So for every addition billion emails sent daily. Our numerator is talking about the change in years since 2000, and it's positive. So we've used the word years since increases by, again, our 0.083 years on average. Okay, so again, we've looked at interpreting the slope several times throughout the linear unit. Again, our inverse function now, again, we're just reversing the input and output, so our units are reversed here. And again, as we solve for this expression where we got the 0.083 and the 1.16, you can go back to the previous problem to see where those numbers came from.